When installing electrical conductors in auxiliary gutters, understanding how to count current carrying conductors is crucial for National Electrical Code, or NEC, compliance and safe operation. The NEC provides specific guidelines for calculating the maximum number of conductors allowed in a raceway, including auxiliary gutters. Let's delve into the relevant NEC articles and calculations to clarify the rules. According to NEC Article 310.15, the maximum number of conductors in a raceway, including auxiliary gutters, is calculated using a formula that takes into account the area of the raceway, the number of phases in the system, and the area of the conductors. The formula is as follows: number of conductors equals area of raceway times number of phases times 2.25, all divided by conductor area. For example, consider a three-phase system with a raceway area of 4 square inches and a conductor area of 0.25 square inches. Using the formula, the number of conductors would be 4 times 3 times 2.25 divided by 0.25, which equals 27. This calculation provides a baseline for determining the maximum number of conductors allowed in the raceway. However, the NEC also provides an exception for balanced neutrals, which can significantly impact the conductor count. NEC Article 310.15b4 states that the count of conductors shall not include conductors of less than 50% of the area of the phase conductors if the conductors are paralleled in multiple non-magnetic raceways. This exception specifically applies to balanced neutrals, which are often used in network systems. A balanced neutral is a neutral conductor that carries only the unbalanced current from a balanced three-phase system. In a perfectly balanced system, the neutral current is zero. However, in real-world applications, some imbalance is inevitable. The NEC recognizes that balanced neutrals do not contribute significantly to the overall heat generated within the raceway. Therefore, they can be excluded from the conductor count under certain conditions. To qualify for the balanced neutral exemption, the neutral conductors must meet two criteria. Firstly, they must be less than 50% of the area of the phase conductors. Secondly, they must be paralleled in multiple non-magnetic raceways. The first criterion ensures that the neutral conductors are not oversized relative to the phase conductors. The second criterion ensures that the magnetic fields generated by the phase conductors are effectively cancelled out, reducing the overall impedance of the circuit. If the balanced neutrals meet these criteria, they can be excluded from the conductor count. This can significantly increase the number of current-carrying conductors that can be installed in a raceway. Let's consider a practical example. Suppose you have 32 wires crossing in an auxiliary gutter, and 7 of these wires are balanced neutrals that meet the criteria for the exemption. In this case, only 25 wires would be counted as current-carrying conductors. The 7 balanced neutrals would be excluded from the count because they meet the requirements of NEC Article 310.15b4. This can have a significant impact on the directing factors that must be applied to the conductors. Directing factors are used to reduce the ampacity of conductors when multiple conductors are installed in a raceway. The more conductors there are in a raceway, the more heat is generated, and the lower the ampacity of the conductors must be. By excluding the balanced neutrals from the conductor count, the directing factors can be reduced, allowing for a higher ampacity for the current-carrying conductors. It is important to note that the balanced neutral exemption only applies to balanced neutrals. If the neutral conductors are not balanced, or if they do not meet the criteria for the exemption, they must be included in the conductor count. In some cases, it may be necessary to use a larger raceway to accommodate all of the conductors, including the neutrals. It is also important to consult with a qualified electrical engineer or inspector to ensure that the installation complies with all applicable codes and standards. The NEC is a complex document, and it is essential to have a thorough understanding of its requirements before undertaking any electrical work. Failing to comply with the NEC can result in fines, penalties, and even legal action. In addition to the balanced neutral exemption, there are other factors that could affect the conductor count in a raceway. These factors include the size of the conductors, the type of insulation, and the ambient temperature. The larger the conductors, the more space they will occupy in the raceway, and the fewer conductors can be installed. The type of insulation can also affect the conductor count. Some types of insulation are more heat resistant than others, and conductors with higher temperature ratings can be installed in closer proximity to each other. The ambient temperature can also affect the conductor count. The higher the ambient temperature, the more heat will be generated within the raceway, and the fewer conductors can be installed. All of these factors must be considered when calculating the maximum number of conductors that can be installed in a raceway. It is important to use the correct formulas and tables in the NEC to ensure that the installation complies with all applicable codes and standards. In summary, counting conductors in auxiliary gutters requires a thorough understanding of the NEC and its requirements. The balanced neutral exemption can significantly impact the conductor count, but it is essential to ensure that the neutrals meet the criteria for the exemption. Other factors, such as conductor size, insulation type, and ambient temperature, can also affect the conductor count. By carefully considering all of these factors, it is possible to ensure that the installation complies with all applicable codes and standards and that the electrical system operates safely and reliably. Remember to always consult with a qualified electrical engineer or inspector before undertaking any electrical work. They can provide valuable guidance and ensure that the installation is done correctly. The National Electrical Code is not merely a set of rules, it is a comprehensive guide designed to safeguard people and property from electrical hazards. Its provisions are based on years of research, testing, and real-world experience. By adhering to the NEC, we can minimize the risk of electrical fires, shocks, and other accidents. The code is constantly evolving to keep pace with technological advancements and changing safety needs. Regular updates are made to the NEC to address new challenges and improve existing practices. It is essential to stay informed about the latest changes to the code and to incorporate them into our electrical work. Continuing education courses, industry publications, and online resources can help us stay up to date on the latest NEC requirements. Moreover, understanding the underlying principles behind the NEC provisions can enhance our ability to apply the code effectively. The NEC is not simply a collection of arbitrary rules. Each provision is based on sound engineering principles and safety considerations. By understanding these principles, we can make informed decisions and ensure that our electrical installations are both safe and compliant. In addition to the NEC, there may be other local codes and regulations that apply to electrical installations. It is important to check with the local authorities to determine which codes are in effect and to comply with all applicable requirements. Local codes may be more stringent than the NEC in some areas, and it is essential to be aware of these differences. Furthermore, it is important to use only approved electrical equipment and materials in our installations. Approved equipment has been tested and certified by a recognized testing laboratory, such as Underwriters Laboratories or all. Approved equipment meets specific safety standards and is designed to operate safely and reliably. Using unapproved equipment can increase the risk of electrical hazards and may void the warranty on the installation. In conclusion, counting conductors in auxiliary gutters is a critical aspect of electrical installations that requires careful attention to detail and a thorough understanding of the National Electrical Code. By following the guidelines outlined in this discussion and consulting with qualified professionals, we can ensure that our electrical systems are safe, compliant, and reliable. Remember, electrical safety is everyone's responsibility, and by working together, we can create a safer environment for ourselves and others. It is also worth noting that the NEC provides guidance on the proper sizing of conductors and overcurrent protection devices. The size of the conductors must be sufficient to carry the anticipated load without overheating, and the overcurrent protection devices must be sized to protect the conductors from overloads and short circuits. The NEC provides tables and formulas for determining the appropriate conductor size and overcurrent protection device rating for various applications. These tables and formulas take into account factors such as the ampacity of the conductors, the ambient temperature, and the type of load being served. It is essential to use these tables and formulas correctly to ensure that the electrical system is properly protected. Additionally, the NEC addresses the proper grounding and bonding of electrical systems. Grounding is the process of connecting the electrical system to the earth, which provides a path for fault current to flow back to the source. Bonding is the process of connecting all of the metal parts of the electrical system together, which creates a low impedance path for fault current to flow. Proper grounding and bonding are essential for protecting people from electrical shock and for preventing electrical fires. The NEC provides detailed requirements for grounding and bonding electrical systems, and it is essential to follow these requirements carefully. In addition to the technical aspects of electrical installations, it is also important to consider the environmental impact of our work. We should strive to use energy-efficient equipment and materials whenever possible and to minimize waste. We should also dispose of electrical waste properly, following all applicable regulations. By being mindful of the environment, we can help to protect our planet for future generations. Finally, it is important to remember that electrical work can be dangerous, and it should only be performed by qualified individuals. If you are not comfortable working with electricity, it is best to hire a qualified electrician. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and correctly. They can also ensure that the installation complies with all applicable codes and standards. By hiring a qualified electrician, you can protect yourself, your family, and your property from electrical hazards. Proper planning is crucial before starting any electrical project. This involves assessing the load requirements, determining the appropriate wiring methods, and selecting the necessary equipment and materials. A well-thought-out plan can prevent costly mistakes and ensure that the project is completed safely and efficiently. When working with electrical circuits, always de-energize the circuit before starting any work. Use a voltage tester to verify that the circuit is de-energized. This will help prevent electrical shock. Additionally, wear appropriate personal protective equipment such as safety glasses and gloves. And avoid working in wet or damp conditions, as this increases the risk of electrical shock. Regular inspection and maintenance of electrical systems are essential for ensuring their safety and reliability. Look for signs of damage such as frayed wires, loose connections, and corroded components. Replace any damaged components immediately. Also, test ground fault circuit interrupters, or GFCIs, regularly to ensure that they are functioning properly. GFCIs are designed to protect people from electrical shock by interrupting the circuit when a ground fault is detected. Proper labeling of electrical panels and circuits is crucial for safety and troubleshooting. Clearly label each circuit breaker with the corresponding load it serves. This will make it easier to identify and energize circuits when performing maintenance or repairs. Also, post warning signs near electrical panels and equipment to alert people to potential hazards. In addition to the NEC, there are other industry standards and best practices that can enhance the safety and reliability of electrical installations. These standards and best practices cover a wide range of topics, such as wiring methods, grounding and bonding, overcurrent protection, and surge protection. Staying informed about these standards and best practices can help us improve our skills and knowledge and ensure that our electrical work is of the highest quality. Remember, continuous learning is essential for staying up to date in the ever-evolving fields of electrical work. Attend training courses, read industry publications, and participate in professional organizations to expand your knowledge and skills. Also, seek out mentors and experienced colleagues who can provide guidance and support. By investing in your professional development, you can enhance your career prospects and contribute to the advancement of the electrical industry. In conclusion, safe electrical installations are essential for protecting people and property from electrical hazards. By following the guidelines outlined in this discussion, consulting with qualified professionals, and staying informed about the latest codes and standards, we can ensure that our electrical systems are safe, compliant, and reliable. Remember, electrical safety is everyone's responsibility, and by working together, we can create a safer environment for ourselves and others. Always double-check your work to ensure that all connections are tight and secure. Loose connections can cause arcing and overheating, which can lead to electrical fires. Also, use the correct tools and equipment for the job. Using the wrong tools can damage the electrical components and increase the risk of injury. Avoid overloading electrical circuits, which can cause the circuit breakers to trip and potentially lead to electrical fires. Know the ampacity of your circuits and avoid plugging in too many appliances or devices at once. If you are unsure about the ampacity of a circuit, consult with a qualified electrician. Keep electrical panels and equipment clear of obstructions. Do not store flammable materials near electrical panels, as this can increase the risk of fire. Also, ensure that there is adequate ventilation around electrical equipment to prevent overheating. If you experience any unusual electrical problems, such as flickering lights, sparking outlets, or burning smells, contact a qualified electrician immediately. These problems could indicate a serious electrical hazard that needs to be addressed promptly. Be aware of the dangers of working near overhead power lines. Maintain a safe distance from power lines when working with ladders, scaffolding, or other equipment. If you must work near power lines, contact the utility company to have them energized or insulated. Teach children about electrical safety. Explain the dangers of playing with electrical outlets, cords, and appliances. Also teach them what to do in case of an electrical emergency. By educating children about electrical safety, we can help prevent accidents and injuries. In addition to the technical aspects of electrical safety, it is also important to promote a culture of safety in the workplace. Encourage employees to report any safety concerns or hazards. Also, provide regular safety training and education to ensure that everyone is aware of the potential risks and how to mitigate them. By creating a strong safety culture, we can reduce the risk of accidents and injuries and promote a safe and healthy work environment. Stay informed about new technologies and advancements in electrical safety. New technologies are constantly being developed to improve the safety and efficiency of electrical systems. By staying informed about these technologies, we can adopt them into our work practices and improve our overall safety performance. In conclusion, electrical safety is a complex and multifaceted issue that requires a comprehensive approach. By following the guidelines outlined in this discussion, consulting with qualified professionals, staying informed about the latest codes and standards, and promoting a culture of safety, we can create a safer environment for ourselves, our families, and our communities. Remember, electrical safety is not just a set of rules, it is a way of life.